Well, Professor Kailat just came back from Shiraz and Isfahan. It was just a refresh of his memory of what he saw in Persepolis. I am very delighted to see at last Professor Kailat here. Actually, since 1980s, I've been trying to bring Tom here. It never worked out. The last time it was 2003, I think, in our ISD conference, but just didn't work out. I've got 2 pages of short bio of Thomas.
Look on the website.
However, I'm not going to read from it. And probably tomorrow morning when Tom is going to give a keynote speech in IWCIT, probably they will read his short bio. But I can give my personal experience. I met Tom about 33 years ago. Probably most of you were not born then. And that was, interestingly enough, in Bludan al-Zabadani, Syria. Okay, I understand part of that is now taken by Daesh and ISIS. He organized a summer school on signal processing, and I went from Sharif University, which was after the revolution. Just a few years after the revolution, I joined, and I was also at that time, at the end of my term, I was the first director of ITRC, this center here that you see. And so we had a few, I think it was a 5-day course, if I'm not mistaken, and Tom, due to his connections, had brought some of the best people from USA, from MIT, from Stanford, from University of California, and other places. And that was where we met, and we made friends, and as a result, the following year, 1984, I believe, through that summer school, I went on my sabbatical to University of California, Davis, and I worked with the late Anil Jain, who died at the age of 43 or something. And I mean, surprisingly, he was a true vegetarian, and so I was surprised that he died of a heart attack, sitting on his rocking chair or something. Anyway, he died after, of course, left University of California, but during that period, Tom invited me to Stanford, and I gave a talk on non-uniform sampling. And when Professor Widrow, I believe, he was organizing those type of talks at Stanford at that time. Anyway, and we had many email contacts to bring him here. It never worked out. And finally, we are happy that he's our special guest. And unfortunately, our guests from USA did not make it because they couldn't get permission from OFAC, although the visa problem here was not the main thing. It wasn't that serious. However, getting permission from OFAC in USA is a big thing because typically it takes about 6 months to a year before actually they issue it. Can you imagine that? The country of freedom and all that, you need to get a permission. It takes about 6 months to a year to come to Iran. Anyways, Tom, recently he got the National Medal from Obama, President Obama, and one of the side effects of that National Medal is that he managed to get that permission very quickly, much faster than the other Americans. And well, Tom got his first degree from University of Pune, India, back in 1956, and then he got his PhD from MIT in 1961, and then he worked at JPL for a few years, and then he joined Stanford. He has produced, I believe, I remember about 20, 30 years ago, he had produced 50 PhD students. So if I use linear extrapolation, I believe he's got about 70, 80, if not more, PhD students graduate. You know, how many, I mean, as professors, I had about 15. Okay, so imagine how productive Tom is. And we are fortunate to have one of his former students here, that's Babak Khalaj. He did his PhD under the supervision of Professor Kailat for about 4 years. And I believe working with Tom for 4 years, he's got some very interesting memories. So I asked him if he has any interesting memory about Tom. He would come and just replace me and just give some of his thoughts about Tom. Babak?
Okay, so yeah, there are so many things, so I just selected a few. Actually, the first one is before I go to Stanford, at that time there was an exam for those who wanted to go abroad from Iran. At that time, we could go everywhere except US if we wanted to get money from the government. So naturally, I didn't apply to US. So I applied to mostly Canada and got admission from University of Toronto. But I was lucky that actually 1 or 2 years before me, my brother-in-law was already admitted, by Professor Kailat, Hamid Aghajan, who is now a professor also teaching at Sharif. So at that time, when I almost was going to, buy very special clothes for the winter, in Toronto, Hamid called me and told me that he talked to Professor Kailat, and Professor Kailat told him that if your brother-in-law is as good as you are, then definitely he should come here and don't worry about money and anything. So that was the first thing that I remember. I'm so grateful that, I was accepted there, and of course in the first quarter, one condition was that I had to pass the quals. But Professor Kailat said, okay, don't worry, you will pass it. So I also fortunately passed that. And but one thing was that in the first quarter I was there, I somehow, Hamid told me that, Professor Kailat is a very serious guy, so you should do your best. So I remember when I arrived at San Francisco airport, about 4 or 5 in the afternoon, and we get to the Hamid's home, he told me that we should have a quick dinner and go to work. I said, which work? He said, no, you have to start working today. So I just, they cooked a pizza, and, I had a pizza, and I was, still had the jet lag and everything. So Hamid took me to the Stanford and gave me a tour. I think it was probably 12 o'clock at night or maybe 1 a.m. or something like that. So we went there, and there was a CIS lab. It was a lab of IC manufacturing. They had fab actually on site at Stanford. And the project Hamid was working on, Professor Kailat tomorrow will talk about that, was related to semiconductor manufacturing, application of signal processing in semiconductor manufacturing. And he took me to the fab actually, and we had to wear these clothes, clean room clothes and everything, and went into the fab and spent about 2-3 hours at night till 4 or 5 in the morning, and he told me everything about the project, So I started, without any delay. So somehow I'm grateful, that Professor Kailat was so dedicated to the work, and fortunately we had very good results. So tomorrow we will talk about, what was the achievements of that project. It was a large group of, all kind of people in that team. Well, a very unique, actually, opportunity, very multidisciplinary work. And I learned a lot during those times, and I continue actually to do that, throughout my career. Every year I have, a course, master's seminar course that tell the students what to do. And the first thing I tell them is, you should think multidisciplinary. You should, when you hear something in one other field that you don't know about, don't close your eyes, and start, browsing internet. Listen to that, and maybe you get some ideas that is useful for you, and then you are the only one maybe in the world that has this connection. And that's what Tom told me, and basically was the education I got. So basically that's probably the first one. The other thing was that every year students come to me, and ask me, what's the project, you're doing, and then, or what project I can recommend to them, which area. And for example, I tell them, go and work in wireless communication. They say, no, be more specific, which area of wireless communication. I say, okay, go and work on, for example, this area, relay networks. They say, no, be more specific, and so on. And always I tell them that when I went to Stanford and Professor Kailat, after, the first few months, and I wanted to decide, what is my project. So I asked Professor Kailat the same question, okay, which area I'm going to work, what's my project? And he thought a little bit and said, okay, I have two areas, two projects. You think about them and select one. I said, okay. And he told me one is signal processing and the other one is control. And communication, signal processing, control, and communication. And I thought a little bit, and I said, okay, select signal processing. I said, okay, that's it. Go and define your project. So I had to spend a couple of months, wandering around, and at that time we didn't have internet, so going to the library everywhere and try to find out, what are the projects in signal processing. And of course we had this semiconductor framework, so I tried to find something that was related. Unfortunately, we did that, and I think we did some good contributions there. So that is also a lesson, something that I tell my students. It's not important that I tell you, a specific problem. You should go and find your own, especially for a PhD student. I don't think you should define the project for the student, so specifically. One last thing is probably when I was in the first quarter, maybe or second one, I had a course, probably the first course with Professor Kailat, and I knew that he is very, serious teacher, and everything should be done very good. So we had a midterm exam, and unfortunately that exam was a take-home, and probably one of my first take-homes. And it was 24-hour time, but at that time it was during the month of Ramadan, so I was fasting also. So it was probably one of unique days of my life, 24 hours, because I had to fast, and also almost 24 hours I didn't sleep, and I was working on these problems. And I fortunately, I think, passed the exam. I didn't get a very top score, but anyway, it was again very, the education, the research, everything was unique. It wasn't taken lightly, and that was why I think lots of things came out of those, research that was directed by Professor Kailat. So these are some, educational and research aspects. Of course, in personal levels, was very kind every time. He never actually asked me to come and, go to his office. I always, went and was very eager to describe what I did, and we had very good moments together. Always, I got some small notes from the articles he read, and just highlighted some parts and sent it to me. Say, these are good connections, follow them, and then I followed them. And another final thing I want to mention is in terms of the role that also Tom played in the general society. And one example I had was from a friend of mine. It was late Professor Alex Gershman. He was in Darmstadt Technical University, and he mentioned before he got a cancer, unfortunately, and died. But before that, he mentioned that there was a friend that got also the same problem and died, and their family was, had some problems, financial problems, and they were looking for some ways of, finding some resources. And he told me that one of the key people that helped in that process was also Professor Kailat, trying to put together some money, and help that family. So these are all different things, in terms of, research, education, personality. So I really am thankful, I got this opportunity to be Professor Kairat. I learned a lot, and I try to somehow also teach my students, and propagate this way of thinking. And I really encourage you, if you can, tomorrow morning also come to, Sharif and attend the talk that is given tomorrow, and you will also learn a lot more on, the way Professor Kailat is thinking, and how he could build something, very valuable over time. Okay, thank you very much.
Thank you.
Well, thank you, Babak. Well, I think Babak is planning to thank his former advisor and his family tonight by inviting them to his house for dinner, and you're all welcome. Well, actually, before Professor Kailat gives his views about signal processing and his contributions at Stanford, I would like to state that one of the reasons and the goals of this workshop, which is the first one of its kind here in Iran, is to establish, first of all, a society, signal processing society, independent of communications or biomedical, whatever, because signal processing has applications in many different areas, including biomedical, control, communications, power systems, microwaves, etc. We do not have to be part of communications in all the Iranian universities. This was the case probably 60 years ago, 50 years ago in the United States. Not anymore. You don't see a mixture of signal processing and communications in current or modern universities in Europe and USA. We are still a bit behind because now signal processing is partly within the communications group, is partly within the biomedical engineering, and it's partly within the computer engineering right now. It's mixed everywhere, as you saw this morning. And we have some people from computer engineering giving talks, some people in biomedical, some people in communications. Actually, we need to have a distinct area called signal processing, whether it is speech, whether it is image, whether it is video, whether it is theory, whether it's related to mathematics. It should be distinct. We need to have our own society, and also the universities should have distinctive groups called signal processing groups. Okay, this is one of the reasons to establish this workshop. And now I would like to ask Tom to give some of his views and talks, and then there will be questions and answers. And as you know, that Professor Kailat is over 80 years old, and I'm surprised that he manages to travel and still give talks. I'm not sure whether I can handle it at that age. Okay, Tom?
Thank you. So, can you hear me? Okay. Well, first of all, I'm very happy to finally be in Iran. Farooq has been inviting me, as he mentioned, for several years, and Babak has also been pressing me to come. And fortunately, it has worked out, and we've been my wife is with me, and her son, and two of our friends, when they heard we were going to Iran, they said, oh, we would like to come too. And fortunately, I got the permission quickly, and then Professor Aminzadeh has been remarkable in making all the arrangements for I was mentioning to Babak, probably we got more than 150 emails in the last few weeks from him with so many details. And our first visit was to Shiraz, where we saw the Shiraz tomb, Pasargad, and the slides reminded me about our visit to Persepolis. So in fact, I would like to get those slides if possible. And of course, Kurosh or Cyrus, it was called the Great for good reason, because of his kindness and so on. So very impressive. And we are coming now from Isfahan, where we had to wake up this morning at 4 o'clock because the plane is at 7. And so if I doze off, you might, but I won't. So a couple of remarks. I was listening to Professor Sodagar's talk, and actually tomorrow I will say something related to, I liked your four things that have to come together: the signal processing, the low circuit design, the low power implementation, and the hardware things together. So signal processing, I've worked in different fields, but in some way signal processing has been the basis of all of those, of many of those studies. Yesterday was the 100th anniversary of the birth of Claude Shannon, the founder of information theory, and he was at MIT when I first went there. He had come from Bell Labs, and I was very fortunate to be in the midst of a wonderful group of students and a wonderful group of faculty also at MIT, because in the field of information theory, and most of the people who worked in that field were at MIT. And Shannon became important in one way because though many people discovered the so-called sampling theorem, if you have a signal band limited to, say, W, you can take samples every 1/2W seconds, and you can characterize a signal of duration T and bandwidth W by 2 TW degrees of freedom. I'll mention this because it's important. Of course, Farokh is a master of non-uniform sampling. So
he's a master of none.
So, because when I went to MIT, time variant channels were a topic of interest because the communication problems were not, mostly it was before that through ionosphere reflection, shortwave radio. But for different reasons, they wanted over-the-horizon radar, where you sent a signal to the troposphere, it was called. The signal got scattered from small moving random and a sine wave, if you send, what will come to your receiver will be a sum of small reflections, random, and so you get a Gaussian process at the receiver. And the question is detection problem. Are you sending 1 or 0 or a Mach signal or space signal? How to detect it from this random signal that you get plus additive noise. So there was a famous communication system that had been invented at Lincoln Lab, MIT Lincoln Lab, by Price and Green, called RAKE, R-A-K-E. At that time, it was a very novel system for combating multipath, because in addition to this random scattering, you also have multiple reflections. And RAKE was a system for separating those and recombining them in the right way. Many, many years later, RAKE is now appearing again in wireless, and all your handsets have some form of RAKE in them, because in wireless you have the same phenomenon. Okay, so it was interesting. So my advisor was Professor Wozencraft, who was also, he was a remarkable person, so excuse me if I just tell some stories. He was in the US Army, and they have the academy called West Point, and he was the first in West Point. But he, served many years in the Army, but they recognized his talent, so they sent him to MIT for his master's degree. and he invented something called integrate and dump filter circuits. Then he went back to the army, but he got bored after a while and he said, let me continue for graduate school. So he came back to MIT in 1955. And at that time, in information theory, the subject was in a strange way, because Shannon showed that there are some fundamental limits to communication, and the surprising result that you can send information at a non-zero rate with arbitrarily small probability of error. And his famous theorem was, there exists some way of achieving this good combination of finite communication rate and low probability of error, but there exists such a way, but no one knows how. He did not say how to find it. And people had been trying for several years, from 1948, to find it, and nobody came. So they thought maybe, Shannon actually had shown that probably a randomly picked code, he had some argument called random coding. You pick a code at random with random waveforms, that may work. But of course, that's not a way of design. You try to find some coding scheme. People thought that all the codes that you can think of are bad, only the codes that you cannot think of are good. Well, Wozencraft was the first person to find a scheme for not achieving channel capacity at that time, but about 1/3 of channel capacity, with a good method for decoding called sequential decoding. He did this in 2 years, and that was the first time anyone in history found some progress in this method. Anyway, so when I came in 57, he got his PhD and was appointed to the faculty. I was assigned to him as his first graduate student. And he was a consultant at MIT Lincoln Lab, because the salaries at MIT were quite low, and they asked professors had to do consulting job to increase their salary. So he said to me, there is this communication system called Rake, but it works sometimes and sometimes it doesn't work, and they're not so sure what are the conditions that makes it possible. So he said, let us try to study this problem of communication through linear, time-varying, random channels. Okay. Now, I should tell you a phrase. At that time, there was a pioneer in the field of linear time-varying circuits. He's from Iran. You all know his name, Professor Lotfizadeh. So, and I knew about his work. He wrote many papers in this field. So I said, Professor Zadeh solved all the problems. He said, no, but those are general linear time-varying systems. In communications, we have restrictions, like the bandwidth of the input signal is limited, and the duration is limited. So we have two constraints, time limitation and bandwidth limitation. So try to study communication systems under these constraints, which are for... Okay. So I say, so the natural thing when you have band limitation is sampling theorem.